Okay, so we have here radioactive decay, nuclide decay. The graph shows count rate per time. The nuclide has a half-life time of 20 seconds. So at time equals 20 seconds, this is half-life time. This means that the count rate should decrease by 50% of the original value regarding the sample. But what we have here is that at 20 seconds, the graph shows 11 rates per second, which is not the half of 19. And this happens because of the background activity. What's background activity? Background activity, like imagine you have a sample. This is a sample under spot. And you have your detector somewhere over here. The sample is emitting its radiation and the detector collects the data and we do the analysis and draw the graphs. But are you sure that the detector is not collecting data or radiation from the atmosphere or from the environment? We know that gamma rays and certain types of radiation can break through surfaces and layers and reach the detector. So here the detector is counting the sample at the major radiation and also counts the environment behind it. And that's what we call a background activity, which is the radiation beyond the sample that we don't need to study or measure, but by coincidence or by the condition of the environment and the atmosphere we need, or it was like an accident, we measured it. So how can we differentiate between the sample activity and the background activity? To do that, we can simply know that at 20 seconds, I need the sample to be at 50%. So here it's 11. So what happened is that the decayed amount through half the time, or the half-life time, it was 19 minus 11, which is 8 rate per second. This means that the original or the initial sample, should be at 16 rate per second. This means that our sample should start from here, from the 16, not from the 19. That means that we have an extra rate or extra radiation, 19 minus 16. This is the extra radiation from the background activity, which is 3 becquerel or 3 rate per second. So the answer here will be